Welcome to Training Module 12, where we focus on the testing and commissioning of the DC Distribution Panel, or DCDB. This module is part of our comprehensive electrical grid training series designed for 2026 standards. Throughout this session, we'll dive deep into the critical processes and protocols to ensure a safe and efficient electrical grid setup. Let's get started. Here we have the reference framework for testing and commissioning the electrical grid. This slide lists key organizations like the IEC, IEEE, ASTM, NEMA, ENSI, SIGER, ICA, and KEMA, each providing important standards and guidelines. It's crucial to apply the most stringent approved requirement when there's a conflict between project specifications, manufacturer instructions, and standards. Also, always document the reference used on the test sheet to ensure transparency and ease of review in the future. This approach helps maintain consistency and reliability throughout commissioning. Here we have the reference schematic for DCDB panels, focusing on MCB and MCCB tests. This includes breaker continuity, MCB and MCCB trip testing, as well as current injection and trip time acceptance. These tests are essential for ensuring the safety and reliability of the electrical grid during commissioning. This schematic serves as a crucial guide for technicians following the procedures outlined in Commissioning Manual Number 12-1. Here we have the detailed test script for DCDB miniature and molded case circuit breakers, focusing on both MCB and MCCB types. The goal is to verify several key factors: continuity, pickup and trip operations, injected current, trip timing, and ultimately final restoration. Before beginning, it's essential to review approved drawings, breaker tags, voltage ratings, trip curves, and safety isolation boundaries. Safety is paramount, so we apply LOTO procedures, set up appropriate barricades, and ensure all PP is worn while confirming the absence of voltage. The testing process starts with a thorough mechanical and visual inspection, checking labels, breaker positions, torque marks, terminals, and panel cleanliness. Then, we perform continuity checks with the breaker in closed and open states to verify proper electrical connections. For trip testing, the injection kits come into play, injecting current according to breaker ratings and curves, while carefully recording trip currents and times for each pole. For MCCBs, we do primary injection tests with rated current multiples and compare the results against manufacturer curves and project acceptance limits. Any anomalies like delayed trips, no trips, or nuisance trips must be thoroughly investigated. Once tests are complete, we restore breakers to normal positions, remove temporary connections, reset alarms, and document the final as-left condition. Acceptance criteria include passing continuity, mechanical conditions, injected currents, and trip times without any abnormal heating, damage, or unsafe conditions remaining. The evidence package consists of test sheets, injection readings, trip timetables, breaker references, instrument calibration certificates, photos, punch list closure, and witness sign-off. Lastly, there's a crucial hold point where commissioning or operations witnesses must confirm proper isolation, test setup, results, restoration, and panel closure before releasing the DCDB to normal service. This ensures a safe and reliable electrical grid operation. Here we have the schematic for the DCDB auxiliary relays and timers, which is crucial for testing and commissioning the electrical grid. This diagram serves as a detailed reference for the DC supervision relay, showing how auxiliary relays pick up and drop out, as well as illustrating timer delays. It also includes important measurements like contact resistance and coil resistance. Understanding this schematic is essential to ensure everything operates correctly during commissioning, as outlined in Commissioning Manual Number 12-2. On this slide, we focus on the comprehensive test script for DCDB panels, specifically for auxiliary relays and timers. The goal here is to verify several critical parameters, including pickup voltage, dropout voltage, reset ratio, timing, coil resistance, and contact integrity. These tests ensure that the relays perform reliably within the electrical grid system. We start by reviewing all relevant documentation and schematic details to understand the relay tag, coil voltage, contact numbering, timer ranges, and acceptable limits. Next, it's essential to safely isolate the relay or timer circuit, removing the relay if necessary, and confirming that no unintended trips or alarms are active. Using a secondary injection test kit and other calibrated instruments, we connect the test equipment according to schematic terminal numbers. We then gradually increase voltage to find and record the first reliable pickup voltage and operating time. Afterwards, voltage is gradually decreased to determine dropout voltage and reset times. Calculations of reset ratio and measurement of coil resistance follow, compared against datasheets or baseline values to confirm compliance. Contact continuity and resistance tests are performed on normally open and normally closed contacts to verify proper function. Finally, after completing tests, the relay is reinstalled, wiring restored, links removed, and system indications verified. The circuit is returned to normal service once all criteria are met. The acceptance criteria demand that all electrical and timing parameters match approved settings and manufacturer limits, with reliable and repeatable relay operation free from chatter or wrong contact states. The result package includes detailed test sheets, calculation tables, timing records, calibration certificates, and photo evidence, all requiring witness confirmation before proceeding. This thorough testing process is vital to ensure the safety and reliability of the electrical grid's protective functions. Here we have the reference schematic for DCDB panels illustrating various component tests. This includes checks for busbar insulation resistance, DC polarity and phasing, as well as testing protection relays, control switches, meters, and indication systems. These steps are crucial to ensure the electrical grid is safely commissioned and operating correctly. This schematic serves as a comprehensive guide during the testing and commissioning phase, as detailed in Commissioning Manual number 12-3. Here, we focus on the testing and commissioning of the DCDB panels, specifically the other component test script. First and foremost, it is critical to verify the insulation resistance of the DCDB bus bars, check DC polarity and phasing, and confirm the readiness of linked components and the final panel condition before energization. We rely on several key references, including approved wiring diagrams, panel schedules, and test packages for CTs, VTs, relays, meters, and cables, as well as an approved insulation resistance test sheet. The required instruments include insulation resistance testers, calibrated multimeters, DC polarity testers, continuity testers, torque tools, personal protective equipment, warning tags, and approved temporary links. The testing process involves several steps. First, confirm the DCDB is fully isolated from all sources like battery chargers and connected loads before beginning busbar insulation testing. Next, review the busbar arrangement, identifying positive, negative, and earth bars, protection links, meters, relays, feeders, and the defined test boundaries. A thorough visual inspection follows, checking busbar supports, insulation barriers, clearances, covers, cable glandings, labels, torque marks, and cleanliness. Then, conduct insulation resistance tests line to ground on all conductors using approved DC test voltages, followed by insulation resistance tests conductor-to-conductor, noting ambient conditions and ensuring each busbar is properly discharged afterward. Polarity and continuity checks are performed from the incomer to bus sections and outgoing terminals using the approved DC reference. It's also important to cross-check that protection relays, metering, cable, and scheme check packages are complete or listed as controlled open dependencies. Finally, restore links, barriers, and covers, and confirm no temporary connections or exposed live parts remain. Acceptance criteria require busbar insulation values to meet project and manufacturer standards, polarity to be correct, barriers and labels to be complete, and that linked component test dependencies are either resolved or formally controlled as punch items. The evidence package includes inspection checklists, test records, photos, calibration certificates, punch registers, and witness sign-off. At the hold point, electrical leads and operations witnesses must confirm insulation resistance discharge, DC polarity reference, restored barriers, and the absence of any unapproved energized conditions before proceeding to functional tests. This rigorous process ensures safety and reliability before energizing the panels.